Right, as we wrap up chapter 4, we're going to look at one more data set. So this one is about homicide and suicide rates in Ohio. So homicide and suicide are both intentional means of ending a life. However, the reason for committing a homicide is often different from that for suicide, and we might expect these rates to be unrelated or uncorrelated. On the other hand, both can involve some degree of violence, so perhaps we might expect some level or correlation in the rates. So the rates that are listed on the spreadsheet tab called death are listed as per 100,000 people. So if the number was 10, that would be 10 out of every 100,000 people. There's also a category for whether some counties should be treated with caution because of low counts. This is data from 2008 to 2010. So that caution note would actually apply if we tried to do something similar here in Colorado. So if you think about the size of Gunnison County versus the size of whatever county Denver is in or the Springs are in, right? There's way more people there. So we would obviously expect that those counts would be higher versus somewhere like Gunnison that's very small. We would expect those numbers to be smaller. So that's what that caution is. So what I'd like you to do is go ahead and pause the video, go ahead and make a scatter plot of these, and then answer those questions. So find the correlation coefficient and describe it, and then we'll come back and take a look at it together. All right, so here's my scatter plot that I made for all of the data for the homicide and suicide rates. I added that line of best fit, and it doesn't look like it's doing a whole lot. This looks pretty scattered, and in fact, that correlation coefficient, I got 0.229. So that is on the side of 0, which kind of matches what we have here. I mean, maybe there's a slight uphill trend, a slight positiveness here, but it's just really scattered and pretty much weak, which makes me wonder if maybe I should be looking a little more closely at the counties that have a caution versus those that don't. And so what we're going to look at next is how to split those up so that we can look at those and see if there is something going on in either or both of those groups. So we're going to hop back over to the PowerPoint and we'll take a look at kind of this new version of a scatter plot. All right, so just like we can compare groups with side-by-side box plots that we looked at in chapter 2, we can also compare groups with a scatter plot. So a scatter plot is used to show the relationship between the two quantitative variables, and that's something we've looked at a lot in this chapter. But we can also introduce a categorical variable, and that categorical variable will color the dots a different color for each group. So the levels of the categorical variable are distinguished using different colors and shapes for the points, and they classify the individuals into separate groups using those colors or symbols. So Excel will do different colors as well as different symbols. It automatically defaults to the different colors, but you could also switch to symbols if you like. So we're going to go back and revisit that death data from Ohio, and we'll split it into those two groups so we can create this kind of two-color scatter plot. Okay, so my tip here, and this is a really important one to keep in mind, we'll go through this when we're in Excel. Make sure that your explanatory variable, that X, is all in one column. And then the response variable, we're going to split into multiple columns. That Y value is going to be in different columns depending on which group it belongs to. All right, so let's go over to Excel and take a look at how to do that. All right, so here we are back in Excel, and I've moved our original scatter plot out of the way. And now I'm looking at this data, and what I notice is this caution column, some are Y's, some are N's, they're just kind of back and forth because this was alphabetized by the county. And it would be a lot easier for me to make this two-color scatter plot if I resort this so that the no's are grouped together and the yeses are grouped together. So I'm going to highlight the county, the homicide, and the suicide rate. Actually, I think I'll highlight this whole thing. So all 4 columns, including those headers, and on the home ribbon, I'll go over to the sort and filter. So we've used this once or twice before, and I'm going to go to custom sort. And that very first box says sort by. So I want to sort the caution columns into groups of no's and groups of yeses. So I'll choose caution there. And then the middle one, I'll just leave alone. And this third one says A to Z, and that's fine for what I want to do. So I'll say, okay. And so now I have all the no's grouped together and I have all the yeses grouped together. So this is going to help me make the columns that I need. So the tip was that the X variable, this is the homicide rate, needs to be in its own column, but the suicide rate needs to be split up into separate columns for the caution yes and the caution no. So I'm going to call this one caution no, and I'll call the next column caution yes. Okay, you'll notice that these are kind of overlapping and causing problems. So you can click between like the cells and drag this over and make this bigger or smaller as you need. You can also just double click on that and it'll automatically expand the width of the column to fit what you need it to. There we go. Okay, so the Y values will be split into two columns and the X values will be all in one column. So I'll copy the X's and paste them over. And then for the Y values, I'm going to take just the ones that are no's. So that's 14.5 to 16.6. Oops. The wrong thing there. Let me grab these again. And I'm going to paste them over under caution no. So you'll notice now that these first rows all have two numbers in them, which is what I want, an X and a Y. These ones only have an X. I'm going to highlight the rest of the data. I'll copy and paste that into the third column. So every row still only has two numbers in it, but now there's like these big giant blank spots, and that's totally fine. All right, so to make this two-color scatter plot, I'll highlight everything, including the homicide and the caution no and the caution yes. The reason for that is it'll make me a nice legend if I do that. So I highlight all three with the labels and put the scatter plot in. There we go. You'll notice it already put a legend on there for me. So that's great. And then let's find the correlation coefficients for these. So for the caution no, it'll be equal CORREL. And I'm going to highlight just the X values that go with the no. So I'll stop here at the 5.8. I'll put a comma and then I'll highlight these Y's. So both of those should be the same size columns. So there's that one. Oh, that's looking a little better, negative 0.469. And then let's see what the caution yeses look like. They look a little more scattered. So I'll highlight just the X's for them, put a comma, and just the Y's. So again, same number of boxes in each of those columns. And oh boy, so 0.02 doesn't get much closer to zero than that. So for the caution yeses, there's really no relationship there. It's just too small of a group. But for the caution no's, so for big cities, there is actually at least a moderate relationship there. Okay, so for those treated with caution, that would be the caution yes. Those are the orange folks here. That's really pretty scattered. I would say it's just scattered. There's really not much of a relationship. For the caution no's, which are the blues, that one was the one that had a negative 0.46. I'd say that the slope or the direction is negative. It's fairly linear. It's moderate, and I don't really see too many outliers in there. So what this two color shows us is that for one of the groups, there really is a moderate relationship there. The other group, there's nothing. And so then when you put them together, you still end up with nothing. And so this allows us to break out some of those patterns a little bit more nicely.